Assalamualaikum warahmatullahi wabarakatuh. Today I will present about Lab 1 Design and Analysis Disc Brake for subject BMMA 3503 Vehicle Brake System. Okay, our lecturer name or instructor name is Professor Madya T.S. Dr. Mohammad Zahir bin Hassan. Okay, we from 3 BMMA S1/1. Okay, our group members is Muhammad Akmal bin Rosli, Ahmad Amirul Iman bin Rosli Anur, Abdul Alim Mohammad bin Azmi, Risshe anak lelaki Jeyaseelan, and lastly Muhammad Aiman bin Borhan. Okay, for the data findings that we can provide is material properties for rotor disc brake. Okay, there is several properties that we can find besides the value and the units. Okay, first is Young modulus. Young modulus is 2.11 times 10 power of 11, and the unit is Newton per meter square. Okay, for the position ratio is the value is 0.291. Okay, third is the density. The density is 7,870 kilogram per meter cube. Okay, for the thermal expansion, okay, the thermal expansion is 1.21 times 10 power of 5. The unit is kilo degree. Okay, for the yield strength, the value is 3.1 times 10 the power of 8, and the unit is Newton per meter square. Okay, for the material, we use iron. And next is the experimental result that we got is von Mises stress. Okay, for this experiment, we need to find the von Mises stress, the maximum and the minimum amount. Okay, for the maximum amount von Mises stress is 2.82 times 10 equal 2.82 times 10 the power of 11 Newton meter square, and the minimum von Mises stress is 6.06 times 10 power of 8 Newton meter square. Okay, the next is the displacement. The displacement for the maximum is 275 millimeter, and the minimum displacement is 0 millimeter. Okay, next we have to find the stress principal tensor. Okay, for the maximum stress principal tensor is 1.53 times 10 the power of 11 Newton meter square. Okay, for the minimum stress principal tensor is negative 1.55 times 10 the power of 11 Newton meter square. Okay, for the table result and the factor of safety. Okay, for the table result is for maximum von Mises stress is 2.82 times 10 the power of 11 Newton meter square, and the minimum von Mises stress is 6.06 times 10 the power of 8 Newton meter square. Okay, von Mises stress, the unit is we use is Newton per meter square. Okay, for the next, for the result is transnational displacements. The value is 275 millimeter. The unit that we use is millimeter. Okay, for the factor of safety, the equation that we use for the factor of safety equal to yield strength divided by ultimate stress. Okay, for the factor of safety that we got from the table result is 310 divided by 282,000. Okay, the factor of safety that we got, the final answer is 1.099 times 10 the power of negative 3. Okay, next for the discussion. Based on the result, discuss the von Mises stress and the factor of safety, that is rotor disc brake. Okay, based on our CATIA drawing shows that von Mises stress, which varies from 282,000 at the highest to 606 at the lowest. Regarding the data supplied by the analysis, we can confirm that our disc rotor is safe to use because the factor of safety is within the acceptable range of 1.099. Okay, lastly, the conclusion. In conclusion, we were able to carry out the experiment for disc brake design and analysis using the CATIA software. We can construct the disc brake in virtual reality and specify the material parameters of the disc brake rotor from drawing. Okay, finally, based on the disc rotor design, our group can figure out the highest and the lowest amount of value for von Mises stress and transnational displacement. Okay, this is the analysis video that we do to find the von Mises stress and the others that we need to find. Okay, in this video, we can find the properties for young modulus, Paschen ratio, density, thermal expansion, yield strength, and we can use the different material name, but the material that we use for this rotor disc brake is iron. Okay, and then we also can find in using this CATIA is the von Mises stress for the disc rotor brake and the displacement of maximum and minimum amount. And lastly, we also can find the stress principal tension for the minimum and maximum amount of stress principal tensor by using the CATIA. Okay, based on the video, based on this analysis video, it is the easiest way if you follow our video step by step to find the maximum von Mises and others for the analysis of rotor disc brake. This video shows step by step on how to do an analysis on rotor disc brake, and it is easy to understand. Anyone can do it by their own. Okay, this is the von Mises stress. We can find the value inside the video. Okay, this is transnational displacement vector. Okay, that's all from our group. Thank you.